Okay, so this is our last video in this section on rational expressions and equations, and this is the applications of rational equations. And so by that, what I mean are word problems. And so in our word problem, we need to read first, then that's going to help us build a chart, and then we're going to use the chart to build our equation, and then we're going to solve. And so this part we saw in the last video, right? We were just given the equation, solve it. So hopefully you practiced that enough and feel confident with that, because we're going to use that skill. And now we have to do this part and this part, which is the tricky part, to decide how to get the equation to solve it. Because we can't get the equation, then I can't solve it. But we're going to look at two types of problems. So the first two are here, where I have a problem that is about people working together. So let's get rid of that. So this says, Betty can deliver 100 newspapers in 40 minutes, and Ron can complete the same job in 30 minutes. If they work together, how long will it take them to finish the job? So what I'm going to do is put this information into a chart. So I have Ron, and I have Betty, and I have together. So there we go. And to do the job on his own, Ron takes, let's see here again, Ron 30 minutes, Betty 40, together sometime t that I don't know. I don't really like using t as a variable, but in this case it stands for time. So this is my first column. And then I'd like to think about, well, what could they do in 1 minute? Well, Ron can do 1/30th of the job because it takes him 30 minutes on his own. So 1/30th in 1 minute, Betty 1/40th, and together 1 out of that unknown amount of time, 1 out of t. And then our last column is, well, what about in t minutes? So Ron would complete t out of 30, Betty t out of 40, and here the time out of the total time, well, that's just 1. So Ron contributes some time out of that 30-minute time he needs, plus Betty's contribution equals 1 completed task, or t over t. And so in this case, you can see our lowest common denominator is going to be 120. So I'm going to multiply this by 120 over 120. And over here, 30 times 4 is 120, and 40 times 3 is 120. So I have 4t plus 3t over 120. I'm just going to write those together, equals 120 over 120. And now I'm going to multiply by the denominator, both sides, to get rid of it. So here I have 7t, and here I have 120, and I just divide by 7, and I get 17.1 minutes. All right, so there you have it. Sometimes kids will do these wrong and will add the 30 and the 40 and divide by 2 and get the average, which doesn't really make sense if you think about it, because Ron can do the job on his own in 30 minutes. If I get the average, I'm going to get 35, which doesn't make sense. You know, if they're working together, presumably it should take less time than it takes him on his own. So 17.1 minutes is our answer. All right, here's another one for you to try. It's basically the same problem, except we have someone takes 3 hours, someone takes 4 hours to do this job. So try here, set up your chart, just like I did back here. So look at what you wrote down for that one. And here, the answer turns out to be 1.7 hours. So for my chart, in 1 minute, I would put in 1 hour, because this one's in hours. Okay, so try that one, see if you get 1.7. And now the second type of problem is sort of these speed, distance, time problems. So this one says, Cheryl traveled a distance of 140 kilometers with her team of dogs to a friend's house and back home. So in my chart, I'm going to have going there to the friend's house and coming back home are my two kind of categories. And then on the return trip, her speed was decreased. Okay, so return, coming back, coming home, was decreased by 6 because of a snowstorm. The total time for the trips was 8.5 hours. What was the average speed for the return trip? So could actually call this return, just to use the same words in the problem. That might be better. So I'm going to put in distance, rate, and time. And those are going to be my categories for my chart in this case. So it says it's 140 kilometers to go to a friend's house and back. So that must be 70 there and 70 on the way back. We're assuming that she's taking the same route. The rate there, we don't know. But we know that on the return trip, it was decreased by 6. So that's the speed take away 6. And the time, well, to fill in the time column, I'm going to use the information that I already have in the chart. And that's typical of these problems, that I have enough information to fill in 2 columns, and I use those to fill in the third. So hopefully you remember that time is distance divided by rate. So if I drive 300 kilometers and I go 100 kilometers per hour, it's going to take me 3 hours, right? So I like to think about this scenario just to help me out with this formula in case I forget. So the distance is 70, the rate is x. And down here, the distance is 70 and the rate is x minus 6. It's 6 less. And now we're thinking, well, okay, great. I filled in the chart, but how do I get my equation? Right here. The total time for both trips was 8.5 hours. So that means that if I think about 8.5, that's 8.5, which is 17 over 2. So this time plus this time equals the total time. And there's my equation. So I could start off by saying, well, x can't be 0 and x can't be 6, because those are my non-permissible values. And then I would also say that my lowest common denominator is going to be 2x times x minus 6. And now I'm going to go through the steps of solving this equation. So the first rational here is mixing the 2 and the x minus 6. Let's see if I zoom in here, if I have enough room to write that in there. X minus 6, x minus 6. The next one is missing the 2 and the x, because I have the x minus 6. So 2x, 2x. And this is missing x and x minus 6. There we go. X minus 6. There we are. So that's kind of ugly. Sorry, I'm running out of space here. But if we clean this. All right, so what I want to do is expand all of this. So 2 times 70 is 140 times x is 140x minus 6 times that 140, well, that's 840, plus 140x, that's this, okay? On the other side equals 17x times x is going to be 17x squared. And then 17x times the minus 6 is minus 102x. And now I have a quadratic, and it's not really a pretty one, but I'm going to move everything over to the right side. I like this to be positive, so I'm going to go 0 is 17x squared. And then I have to move these 140s over, so, and combine them with this negative 102. That gives me negative 382x. And add 840, this, the constant, and that equals 0. And now I'm not really going to be able to factor this off the top of my head, so I'm probably going to use the quadratic formula to help me out. So x is 382 plus or minus the root of negative 382 squared, which is going to be a positive number, watch that, minus 4ac all over 2a. And so if I do that, I end up with 382 plus or minus 298 all over 34. And so that spits out two answers for x. I get 20 and I get 2.47 as my two answers. And so if I look at my chart, if I put in 2.47 for x and I take away 6, I'm going to get a negative rate, which we don't really like in math. So maybe you guys do that in physics, but in math we don't. So there it is, 20. So that's my answer. The speed going there is 20 kilometers per hour. And on the way back would be that 20 minus 6, so 14 kilometers per hour on the return. So the speed on the return trip was 14 kilometers per hour. All right, so here's a very similar problem. Oops, zoomed in too much. There we go. Liz and Donna are taking a train from Madrid to Salamanca. The distance between the cities is 160 kilometers. Okay, if the train slows down by 16 kilometers per hour, the trip would take half an hour longer. What is the train's regular speed? So in this case, we're going to have two scenarios. So we have regular speed and we have slow speed, right? If it's slowed down by 16. And again, we're going to do our distance, rate, time chart. The distance is right here, 160. And the rate for regular is just the rate, whatever that is. But if it slows down by 16, then something will happen. And so similarly here, I'm going to put in the time as 160 over x, and here 160 over x take away 16. And now what I would do is say the trip would take half an hour longer. So the longer trip is the slow one, right? And this is half an hour longer than that. So I have a couple of ways I could do this. I could say that, well, the regular trip is equal to the slower trip minus that half an hour, for example. You could do that, or you could do this trip minus, sorry, the longer trip minus this one is half an hour. There's lots of ways you could do that. But why don't you try solving this one? So that's how we got the equation. See if you can solve it. And you get two answers, but again, one of them turns out to be a nonsense answer. Oh, whoops. Sorry about that. There we are. The answers you get at the end are 80 and negative 64. And again, you get kind of an ugly quadratic to solve, but I think it's good practice to go back to what we learned in quadratics. So yeah, try and finish this one off. See if you get these answers. This is the answer. This, of course, we'd throw out because it's negative. And then after that, here's some